We're going to look at adding, subtracting, multiplying, and dividing functions today, along with the idea of composition of functions. Here's function f. It says square your input and triple that, and then add it to what you get when you multiply your input by 7. Function g says square your input and subtract 1. To begin with, you're going to want to go f of x plus g of x. That means just add your two functions together. So you want to go f of x, and then add to that your g of x. And so now you're going to just go ahead and combine like terms. We have some x squareds, 3 of them, plus 1 of them gives you a total of 4 of them. It's your only like term, so you just bring down the rest of them. Here it says take your two functions and subtract g from your original f. So here's f. And then we got to go subtract, and now we got to subtract g. Remember to subtract the whole thing, so it really needs to be in parentheses. So we're going to take our f. Now to get rid of the parentheses here, you need to distribute the negative through to each one of these two terms. And we get this. Now we can go ahead and combine like terms, which once again are the squared ones. You have 3 of the x squareds minus 1 of the x squareds, leaves you with 2 of them. Then you'd still have your 7x and your 1 hanging around. Now, we next need to do this. It's f of x times g of x. So you need to go ahead and take your original function of f, plug it in here, and then you got to multiply that by your original function g, which is an x squared minus 1. Then we need to get rid of the parentheses, so you're going to have to FOIL that out. You multiply your first terms together. It'd be a 3x to the 4th. Then you want to go ahead and multiply your inner terms together, and you get a 7x cubed. Multiply your outer terms together, and you get a minus a 3x squared. And then multiply your last terms together, a minus 7x. Now, the last one over here on the right, f of x divided by g of x. You want to take your original function f, which is your 3x squared plus 7. You want to divide that whole thing by your g, which is your x squared minus 1. Now, you're not able to cross out your x squared here on the top and the bottom because it's not x squared times the whole top and an x squared times the whole bottom. At this point, there's really nothing we can do to simplify this fraction. We have no common factors on the top and the bottom. Yes, the top and the bottom both factor, but there would be nothing the same on the top and the bottom. But we do need to be aware that since we have variables in the bottom, that we cannot divide by 0. Now, question is, what causes the bottom to be 0? Well, if we did set the bottom equal to 0, this is differences of squares here. It's an x plus 1, and it's an x minus 1 equaling 0. So from here, you get x to be a negative 1. From here, you get x to be a 1. Those are the two numbers that you can't let x be. Because if you let x be 1 or negative 1, it would cause this expression to be undefined because you get a 0 on the bottom. So after you do your dividing, you also need to specify what you cannot use for x. Now, here we're going to look at composition of functions. With composition of functions, you're pretty much taking one function and putting it into another function. Here we have a function of 2 that you're putting into f. We've looked at this before. In other words, you go up to your rule and you plug in 2 for each one of your x's. So you get a 2 squared plus a 3 times 2, which is really a 4 plus 6, which is just 10. Here you have function f, and it says you need to plug in triangle. So you need to go up to your function, replace both of your x's with triangle. So you get a triangle squared plus 3 times triangle. And in this case, since they're different terms, there's nothing more we can do to simplify that. Then we have f of box, and whatever's in the parentheses is what you got to go up here and plug in for x. So you get a box squared plus a 3 times box. Once again, these are not like terms because the exponents are different. We can't do anything to it. Here's an example of a composition of functions. Now, this notation right here is identical in meaning to this notation. If your book happens to use this notation here, you can always go ahead and rewrite it like this. It means the exact same thing. What this says is you have your function f, that's on the outside. G of x, I'm going to replace g of x with what I know g of x is, the 7x minus 1. So inside the big set of parentheses, I replace g of x with 7x minus 1, since they are equal up here. Now I need to go to my function f. It says I need to square my input and then add 3 times my input. Well, I need to square my input, but my input's everything I have in the parentheses here. That's my input. So that's what I need to put in here before I do my squaring, and that's what I need to put in here before I do my tripling. So I'm going to replace this x here with what's in the parentheses. So I get a 7x minus 1 all squared here plus a 3. And since I got to put it in also here, I need to have a 7x minus 1 because that's what's in my parentheses. Just like up here, whatever was in the parentheses is what we plugged in for x, and that's what we did here. We had a 7x plus 1 in our parentheses, so we had to plug it in here and here. Well, all we're going to do at this point is just simplify it a little bit. 7x minus 1 all squared is really a 7x minus 1 times a 7x minus 1, and you'd have to FOIL that out. Here, you'd have to just distribute through your 3. And now we can combine our like terms. Once again, the reg came from this right here of a 7x minus 1 times a 7x minus 1 and FOILing that out, because squaring means multiplying it by itself. Combining your like terms, we get this. Now, just as a refresher, g of x is 7x minus 1. Now, you're asked to work this one out here. This is another composition of functions. G of 2, you always got to work from the inside out. So you got to go to function g and plug in 2. So you go 7 times 2 minus 1. Well, 7 times 2 minus 1, that's 14 minus 1, that's just 13. So the whole inside of g of 2 reduces down to 13. Now it's just f of 13. Remember, f of x was your input squared plus 3 times your input. So f of 13 means you got to square your input and add 3 times your input. So you get 39 here plus 169 gives you 208. Well, we need to do a similar type of thing over here, but now we're dealing with g's. You have g of 3, so you got to go to function g and plug in your input of 3. And remember, g just says 7 times your input minus 1. So 7 times your input of 3 minus 1 is 20. Here, you got to go to g, replace your input of x with triangle. At g of box, you got to go and replace your x with what's in the parentheses, which in this case is just box. Down here is composition of functions. You're taking one function, putting it into another function. That's all composition of functions is. Says you need to take g, which is 7 times your input minus 1. So I have 7, my input here, minus 1. But in this case, my input is f. So I need to take this right here, which is f, plug it into my function right here. So it's 7 times my g, and then minus 1 after that. Well, if you distribute through, we just end up getting 7x squared plus 21x minus 1. So now, let's go down here and look at this composition of functions. Since we have a number on the inside, we should be able to work this out. We figure out f of 5. Remember, f was your input squared plus 3 times your input, and here our input is 5. So you need to go 5 squared plus 3 times 5. That's what we have here. So you get 25 plus 15, which is just g of 40. So now that we have the inside reduced down to a number, we can go to g, which is 7 times your input minus 1, but our input's what's in the parentheses of 40. So we work that out, and we get this.